Hey. All right, hey guys, my name is Kevin. This is my friend John. We work for a company called Cisco. We make like paper plates and paper forks and those sorts of, just kidding, of course. We make networking equipment and do some other stuff. But today we wanted to talk to you guys about password rotation and sort of how that fits into a larger need for validation and verification of your software and like your entire software development lifecycle and all kinds of good stuff like that. Strategies to make password rotation less painful. And we're going to do it kind of in the context of Ansible. And yeah. So a little bit about us. We've been working with OpenStack since Bear. So we've been doing OpenStack for a very long time. We helped bring it to a large telco with some other friends of ours. Excuse me. We went to our first summit in Santa Clara. That was a Cactus summit, and that's where I met my friend Mr. Pipes. And we fixed a bug in Glance, and we were friends ever since. It was good.
I think you were more of a fanboy, though, at the time.
That's true.
Yeah.
And so my favorite summits, our favorite summits together probably were in 2012, the San Diego and San Francisco ones. It had just gotten big enough that there was a lot of really great information and a lot of like really big talent coming in, but it was still small enough that you could actually go to every single one of them. So whereas after that, it's like, there's so much good stuff, I can't get to all of them. So those were my favorites. And also I went to college in San Diego, so it was good to go back there.
Yeah, and they had good burritos too.
Excellent burritos. Yeah. All right, excuse me. Our friend Adam Brown, whom we work with at Cisco, he helped to develop all this stuff, but he couldn't be here today, so we wanted to give him a shout out. He just lives in Parker too, so he's which is not far from here, so he's just a big old slacker.
Just everybody start following him on Twitter, so it's kind of freak him out. Yeah. All these random follows from people.
Like, who are all these people? All right, so our intended audience here, we're going to make a few assumptions. We're going to assume that you understand Ansible, you understand what OpenStack is. Like, we're not going to talk to you about what a role is. If we say something like Cinder or Neutron or whatever, we assume you know what that means. We also kind of make an assumption that you've deployed or operated OpenStack before. So like when we're talking about, oh, you need to do this or that you sort of have a context for what we're talking about. Or additionally, people who are interested in developing and employing these kind of this SDL, I'll probably call it, but the secure development lifecycle thing. Or planning day-in operations, and this is clutch. So like a lot of times what happens is we start developing software, and that's great, but then all of a sudden we release it, now it's like, oh my goodness, how am I ever going to maintain this? So sort of talking about that from the start of the development cycle. So if you're interested in that, then this is hopefully the talk for you. Or just creating patterns for reusable code and infrastructure. Those are the sorts of things too. It's like not invented here syndrome is big in a lot of different companies. And so it's like, we're not going to reuse that, we're just going to write. And even within the company, like within BUs or within teams, everybody just sort of recreates the wheel over and over and over again. Or just generally, if you thought this sounded interesting, and I guess you're either accidentally here or you thought it sounded interesting, so you're here. So it's also for you. So to start with, why? That is a good question, Dr. Ryan Reynolds. Because if you just had to change your password in one place, that would be super easy. Unfortunately, you've got gajillions of systems. You've got passwords all over the place for gajillions of different services on different systems. That would be super easy if you didn't have to change, if you only had to change it in one place. We don't really have to. Oh, you don't say. Of course, Nick Cage is. So on our team, we're like fueled by coffee, memes, and rage. And so you're going to get, I have a lot of coffee this morning. You're going to get a lot of memes, hopefully not a lot of rage. But we'll see. Ansible does sometimes give me the rage. So we're going to talk about some strategies to implement password rotations, and we're going to go over some specific Ansible roles that we've written. So Dewey will delve into that from a technical level. And then we're going to go over some higher level strategies just for implementing these secure development life cycles from the very start of a project. So it's not something you want to have as an afterthought. And then some ways that we've worked specifically to kind of lower this barrier of entry for validation and automation. A lot of times it's so onerous to implement that like the tooling isn't good or it's difficult or whatever it is. There's just a lot of work to get in there. So if you can lower that barrier of entry, you can get more people doing it, it's a lot better. So security is often viewed as unnecessary. I've had this conversation with, well, I'll just say a certain level of management. If you have a security sort of like this, where there's something going on and your security policy is just looking at it and going like, yep, that seems like a violation, that's not really super useful. You need something with a little bit more teeth than that. So next question we're going to ask is like, so, well, why do we even need to change passwords? Like to that security question, it's thought of afterwards. So a few good reasons. Obviously, there's a ton. Hopefully there's nobody from Facebook here because they've been in the news a lot lately, and so I'm just going to pick on them a little bit. But poor password policies are one reason that you sometimes need to change it. You know, if somebody's allowed to make 1, 2, 3, 4, 5 their password, or what is it, OpenStack 1, 2, 3, I think was like a default password for a really long time. You know, not enforcing reuse policies, not enforcing, you know, different management policies, complexity policies. That's one reason you might need to change them. Just software practices in general exposes your data, and now all of a sudden, hey, there's, you know, your hash is part of somebody's rainbow table, and yet anytime that password gets used anywhere, you're done. Configuration management as well. So like, if there's not a bug in your software, but like you don't fix the permissions on a directory or something like that, you leave it wide open, passwords are gonna get taken. And then, or just poor validation of your software prior to release. Like if you think, oh yeah, I wrote bug-free code, right? I can't even write bug-free hello world. So I surely can't write bug-free anything else. And this isn't just limited to you, because especially like in container world, you pull in tons of stuff from other people. Oftentimes we assume that they've done sane things with it. I can assure you that is not a safe assumption. And then, of course, there's far too many other reasons to list. You guys have read all the things. So password rotation in Ansible, or sorry, in OpenStack with Ansible. I'm going to hand it over to my friend, Mr. Dewey, here to talk about that, and I will get out of your way.
Why, thank you.
You are welcome.
So we're assuming there's a few different types of deployments there. Obviously, maybe more, maybe less, but we're coming from the self-managed. And really, what's the difference between self-managed and managed? Managed is really self-managed, but by somebody else. So, you know, there's homebrewed that you guys have either deployed Ansible with a bunch of, or deployed OpenStack with a bunch of automation that you wrote yourself, or that you know, got off the internet from somebody or someplace, or you're using like OSP, OpenStack Ansible. All of those types of things, but more or less, we're going to focus on the self-managed aspect of this. So you kind of need to think about what you're trying to accomplish. If, you know, we're going to change passwords for Nova, for the Percona password for Nova, then we're going to need to think about what exactly does that entail? How is it deployed? What services do I need to stop to make sure that when they start up again that they're reading in the new password? You just kind of need to know about your deployment. If you've written your own automation, then you kind of have an understanding of what is involved. If you haven't written your automation or using some other service or some other deployment, then you're going to kind of need to understand, they may have solved this for you, but if they haven't, you're going to need to understand how it's deployed so you know what you need to do. OpenStack Ansible is, you know, container-based, so, you know, what they do may be entirely different than kind of what I'm speaking to here, but really the same rules apply. You need to know what to do and how to orchestrate it before you can kind of apply those changes. This also applies, you know, and really, when trying to make reusable code, you don't really want to spend time optimizing for things you may never need. So with that, we'll dive into, you know, kind of how we've designed for reuse. Granted, you can see this is probably a somewhat of an old implementation where you're going to see pacemaker in there. You know, nobody really uses pacemaker anymore, but obviously for our product and what we were doing, this made a lot of sense at the time. And as you see, a lot of the services are broken out into components. You know, rather than just saying, having a main and saying, let's go ahead and install Cinder, and let's assume that the handlers will stop things when they need to stop things and start things when they need to start things. We've broken it out to be very, you know, components, so that what we can do later is we can orchestrate those services externally. So if we need to install OpenStack, we can install OpenStack. But if we then need to later restart the service or start the service or do something to that specific service, we can target the task necessary for doing that. So this is kind of how we've gone about thinking about how we lay out our roles. And we've done this across all of our services, and it makes it very easy when changing passwords to say, okay, well, I need to change the RabbitMQ password, which is notoriously difficult. So let me first change the password in Rabbit. Then let me figure out, well, what do I need to start? What do I need to start? And by having these hooks in your roles, it makes it very easy to do that.
Very reusable.
This is just a high-level kind of play to show how we've actually accomplished this. But let's drive into it. Let's drill into it a little deeper. So more or less what we've done is we've reused all of our tasks. And we are basically targeting the tasks to say, on this particular set of hosts, go ahead and unmanage it through Pacemaker again. Yes, we're using Pacemaker. Unmanage it through Pacemaker, stop the service. Then we have a little task in there that will look up the password from our inventory, change just that specific password for Rabbit. And then once we've done that, we then need to start the services back up. So we go ahead and start the services up. The skip handlers that you see in there is unique to us, but the point being is we're not relying on handlers to see a change and allowing handlers to restart it. We do it, we're explicit with it ourselves. We found that handlers can be troublesome, particularly if a handler fails or a service renders a template and you expect that template change to then restart something. If something went wrong in between those two places, your service, when you rerun Ansible, is never going to start back up again unless you're explicitly telling it, to look for that. So this is just kind of the patterns that we've established. And a little bit more of a complicated role. Again, it's the same. You're doing the same thing, but this is changing the password across Nova Compute. So you can see we're doing something very similar. We're targeting the controllers, but also in addition, we're targeting the hypervisors as well. So you can see whether it's a simple one password or whether it's one service or it's a service that has many additional components around it. For example, all the conductor and any of the other components. It still can be handled in a similar fashion by just targeting those specific tasks that you want to target. And by having it laid out in the way that we laid it out, it makes it kind of a lot easier to do. And this can also, these principles can be applied to other, if you didn't happen to write all this automation and you're using another framework to deploy OpenStack, and that framework doesn't have the capabilities to restart passwords, you can still write your own Ansible, and a lot of the times you can hook into those roles and perform actions within those roles.
One of the things I like you've done here is you want to talk about this common YAML and under tasks and how we've reused the code there. And
oh yeah, so I mean that's more or less just a way for us to, we have a common task that more or less does some pre-checks to ensure the system has a particular state and it won't continue unless it matches that state. I probably should have dove into that or kind of dove into that deeper, but more or less it's a way for us to just ensure a particular state is met before continuing on. And the reason it's included is because we use that across almost all of our playbook changes. So what does this have to do with how I develop software?
that is a good question. Excuse me. We should talk about that.
Oh, we should, yeah. Go for it.
You guys remember this slide about why you need to change your passwords? If we develop software a little bit better, if we can maybe implement some smarts in our development lifecycle, hopefully we can avoid having to change passwords a lot. Maybe you probably won't be able to avoid writing a password changing Ansible stuff, but one of the things we did in there, obviously you saw we reused a lot of code. We had common things to maintain state or to check state, ensure state. So one of the questions like we talked about before that you can ask yourself is that where do your containers, your VMs, your modules, where are they coming from? Do you know? Do you have any way to audit that? Have you thought about ways to audit that? once you get them, do you do any kind of introspection on them? So at Cisco, we use a bunch of different tools, some of which are commercial tools, to introspect on our containers. And what we discovered was horrifying. I won't throw anybody under the bus, but Alpine is terrible. And so if you're using Alpine, I would encourage you to reconsider it, and we can talk about that later. So do introspection on it. Don't just assume that what you're getting is good and that somebody else has done their due diligence and has made sure that, that there's not some kind of major issue. And also, like, find out what their build process looks like. How often do they build? Like, how often do they commit? We've seen lots of issues, too, where you get a container and it's got some old version of some software that had some critical vulnerability in it, like a 10 CVE, and it hasn't been updated by whomever was maintaining it upstream. They've updated the container, but whatever package has the problem that they're importing hasn't been updated. There's this crazy dependency. Sorry, I thought you had something to say.
I did, but there we go. Or the software has been updated that ships in the container, but the base OS is old.
Right. So especially containers the whole layered file system thing has caused a lot of need for doing introspection and just looking at understanding, which kind of brings me to my second point. So one of the things we've done at Cisco is a lot of containers, we decided this is just too much trouble, and we've started building our own. But then, of course, that opens up, like our own base containers, I should say, but that opens up a whole other can of worms because now I'm responsible for all the things I'm upset at all these upstream people for not doing. So if you're building your own, again, all these questions apply. Like, what are you doing to make sure your software is updated? What does your CI pipeline look like? What does your validation pipeline look like? And that's kind of more on the gate job side. How do you make sure that your container looks the way you expect it to? That minimum versions of software are met. We have product security baselines, or PSBs at Cisco, and it's like this giant list of things that you have to make sure you've accomplished. And so from an internal compliance perspective, this is something that's been really important to us. We've had to look at all this, and so that we can actually not just say, yeah, we think it's updated, but we have to actually provide proof that it is. So what does your validation pipeline look like? Another good question to ask yourself. Into the day 2, 3, day N operations stuff, how are you going to manage this later? Like, so you wrote it, great. Hopefully it's secure when you wrote it, probably not, at least not if I wrote it. But eventually I'm going to need to update it. And so what is that going to look like? Or do you plan to update it? I mean, I would hope so, but maybe you don't. And that's a question you have to answer for yourself. How do you continue to validate the updates? So it's like, okay, well, you did it once, but things have changed. Are you continuing to do that as you continue to move forward? How do you deploy these updates? Do you use some kind of orchestration? Is it somebody who just logs into a machine and types Docker pull, or I don't know, whatever the Kubernetes version of that is? Or if you use Docker Compose, I guess you can pull that way too. Like, what does that look like for you? How do you deploy these updates? Or, I mean, even if it's not a containerized or a VM version of a software, if it's actual shipping software, it's like, well, you upload it to a website and then people download it and they run it. And it's like, okay, well, do you have SHAs? Do you have, God forbid, MD5s? Like, whatever it is to make sure that the software that you actually put up there is what you think it is. I think there was a problem with Docker Hub with Docker where they just had a thing where, like some GitHub tokens got compromised, and there's all sorts of things where, I mean, obviously you can't protect against everything, but implementing some of these things can help prevent those sorts of issues happening. And then lastly, how do you validate that it was actually deployed correctly? Because you do all of these things and you put pristine software up there and it's ready to go, and then you deploy it and something doesn't go right. How do you know? Do you know? Hopefully you know, and then, I mean, I guess something that's not on here too is like, how do you fix it if it turns out that it's not? What kind of feedback mechanisms do you have? And so in this case, I'm talking, I mean, it can be for anything, but I'm talking specifically about like customer feedback. So if somebody comes to you and says, hey, I found a bug in your product, like, how does that get handled? How does that get managed? How does that get prioritized? Does it end up in the Jira queue and it's like, priority 4 at the bottom of the Kanban or whatever? Like, who knows? And do you have an embargo system in place? Like with OpenStack, for example, when you submit a bug, there's a little checkbox, at least there used to be, I haven't done it in a while, that says this is a security bug. And if you do that, it doesn't display it to the public until people have had a chance to look at it, figure out what's going on. So like, do you have something like that in place? Because the last thing you want is people filing bugs, especially if you're running like an open source project. Somebody's like, GitHub issue, hey, by the way, like your software is prone to all these things, and then probably before you fix it, it's already been exploited. So yeah, think about what kind of feedback mechanisms you have. And then last but not least, in this slide at least, how do you enforce all of this? Kind of back to that security slide with the security guard who was just taking a picture of it. It's like, having a security policy is great, but if people don't follow it, oh my goodness. And that's something we're dealing with as well. I mean, every company and every big or small deals with it. But how do you enforce it? Do you enforce it through technology? Do you just fire people who don't follow it? It's super important to figure out how you enforce it, because otherwise it's like my dog. He barks really, really loud, but then you look at him wrong and he turns and he runs. It's like not super useful. And he's a big dog, so you would think he'd be scary, but no, he's not. So one bad config on one component can bankrupt the entire company. And of course, Guilfoyle has a much more colorful way of saying it than I will. But at the end of the day, that's kind of what you're trying to do. You want to make sure that the smallest of things is not something that shows up in a quarterly earnings report. Like that does not end well for you, for anybody. For me, if I own stock in your company. So yeah, make sure that you're not that guy. Do the best you can. So Dubert, you want to take it from here?
Sure. Why not? So obviously our takeaways, understand your deployment. We've kind of touched on that quite a bit. You're not going to be able to do what you need to do if you don't understand how your system's deployed and how your system's laid out, your services run. That's kind of paramount. We had to throw a molecule in here because really you should test and validate what you're working on. If you want to change if you have all this automation to change a Percona password, then you can mock all that up in Molecule, and you can, run a very slimmed down Cinder, and you can then run your playbooks on it, and you can validate that it's stopping and starting and changing passwords the way you want. And so,
So Molecule is a test framework for testing.
So Molecule is a test framework for Ansible. Red Hat is currently developing it. And so that's definitely a very good project to use if you're unfamiliar with it. I suggest looking into it further.
But you don't want to just stop at roles and plays either.
Right, you don't. You really want to understand all aspects of what you're doing. Plays and roles are one. Containers and understanding what's in the container is another. We currently have an internal project. Unfortunately, we still wanted to bring it up because it's something that we use. But Boxliner, and it validates that containers are built the way that they should be built, and they adhere to certain security aspects. And so it will boot up a container in any using Compose, and it will run a bunch of test infra tests against it, including a lot of the CIS compliance tests and any other tests that we have, so that any container that we've built, number one, we've ensured that it functions the way it's supposed to function, but number two, it meets the criteria that we require to meet. And also, really another key takeaway is just making things reusable and accessible. And I know you had some good stuff to talk about that.
Yeah, automation is clutch to making it reusable, because you want to make sure that everything is repeatable, and so getting it on there over and over and over again. I know when I log into systems, I rarely type the same command exactly the same twice. However, something like Ansible or Chef or Puppet or whatever you use is far better at that. Machines are good at that. Humans are bad at that. And then considering how you're going to sustain this forever, as early as possible in the project, is another huge key takeaway. But yeah, reusable automatic validation frameworks and tooling, it lowers and this is, I think, one of the most important parts. You lower the barrier for entry. So if we take like a walk down kind of computer history lane, back in the old days, you would have these giant, well, I'll go a little bit further forward than mainframes, but let's talk about Fortran, and you've got stacks and stacks of these cards. And that was like a really high barrier to entry to be able to, if you wanted to create a Fortran project, it's like you had to be a pretty specialized person with access to specialized equipment. You know, kind of fast forward a little bit more, and it's like, well, now all of a sudden there's a compiler for it. So people who may not have had the expertise necessary or the access to the resources necessary to write those programs, now all of a sudden, you know, with their $5,000 IBM compatible or Apple II, whatever, can now start writing programs. And so you expand the bubble, you start getting a lot more diversity of people, a lot more kind of investment into the ecosystem. And then, you know, you fast forward to today, and now, I mean, anybody can write just about anything. My kids, like, pull up stuff on their tablets, and they're like, Dad, I'm programming, and it's like usually playing an annoying song and some silly animation of a person doing whatever, but, you know, literally my 6-year-old is doing the basic concepts of writing programs. And so lowering the barrier of entry is like this, it's super, super important. So at Cisco, some of the things we've done with this, obviously we write a lot of tooling that we try to make it as easy as possible. Like we could do a whole talk on that boxliner thing. If you've ever used Molecule as well, it's the same kind of thing. It makes it so that instead of having to spin up your container and then like run a bunch of inspect tests on it, you just type a command, does it all for you, nice and easy. But then the beauty of that, you can take it and make it bigger. So we have a project we call Stadium Gate, which is common CI infrastructure that anybody in our organization currently can plug into. And so not only now do you not have to set up your own Jenkins and your own, you know, whatever else, but you also can reuse a lot of these modules. So you can say, oh, well, I'm building containers and I'm running it through this CI pipeline. I want to make sure that they meet Cisco's PSBs. So you can say, okay, well, include this little bit of Groovy in your Jenkins file, and it will run Boxliner, which will then pull in these, you know, all of these upstream repos that our security and trust organization has provided. And now you get that for free. So, well,
same for Molecule, yeah.
Yeah, and same thing with Molecule. So you get all this validation that you don't have to work very hard to do, and so then people are more likely to do it. They're gonna, you're like, oh, well, all I gotta do is, and he's like, I just have to change this and then change these little variables, and I get all this testing and all this validation for free. Well, sure, I'll do that. And so then you start releasing better software and make a better impact on your, like a larger impact on your organization. I think our work here is done. I hope our work here is done. So I realize we finished a little bit early, but does anybody have any questions or comments or thoughts or criticisms?
Is Boxliner going to be open source?
We would love for that to happen. It's really early in its development at this point, and then there's all the other things that we have to deal with in order to make that happen, but that's certainly
That would be the plan. I mean,
that's the plan, but
it originally was and then kind of got hidden away.
these things happen.
Yeah.
But yes, we would love to do that, and I mean, if anyone's interested in Boxliner, we can certainly show you demos of it. It's just Python that wraps inspec.
Yeah.
Yes, sir. I'm sorry, say that again?
Why not use MFA, like certificate authentication, when jumping into your OpenStack model?
That's a good question. I haven't deployed OpenStack in quite some time, so it's possible it just didn't exist when we were still doing it. I'm sorry, I don't have a good answer for you on that. I'd love to hear about it though, so if you want to talk about it afterwards, because that sounds interesting. Maybe I can include it in the next time I present this. What kind of pre-checks? The question was, what kind of pre-checks are we doing in our common role?
I think a lot of it involves like make sure that the password that we've grabbed out of the inventory actually exists. You know, so it just doesn't have an empty value. Ensure some services are actually stopped as well. A lot of the times, if we happen to run into a bug when initially working on this and we found that bug seems to crop up, we might do a check for that as well. I don't remember offhand all of the various things we do check for. I can go look it up if you're interested. Yeah.
Yes, sir.
Have you got like books that would be usefully consumable to the public?
No.
That's a good, yeah.
This is based off of our product, and so you know, one can talk about why, you know, that's the case, but yeah, ultimately it was our product, and so yeah.
Well, you could see in the role names they all started with Cisco dot and then whatever it was,
Yeah.
and that's because it was all written in-house or
But-
specific for our deployment and
Right.
our product.
And honestly, that's kind of, I mean, really if you think about kind of just the way to lay it out, and you just kind of start thinking that way, I don't know if necessarily you need the playbooks per se. It's more about just kind of thinking about how you want to lay stuff out when you're doing it. Because to be honest, when we first started working on that, you know, 4 or 5 years ago, we didn't think about password first originally. And as we started developing this and realizing, you know what, there's some compliance issues and we really need to tighten this thing up, that's when we started refactoring it and kind of learning the patterns that really worked for Ansible and for our product. And we started breaking things out into what you saw there. But that's why we kind of at least wanted to tell people, hey, when you're doing this, kind of think about those things. Because quite frankly, I doubt many people do. And it's, you know, when somebody leaves or, you know, you find that you do need to change passwords, it's not an easy task. And a lot of times you just throw it over the wall to ops and say, hey, you guys go deal with it. But that, in our opinion, isn't the right way to approach it.
Yeah, I wonder if it could be part of the Ansible hardening framework.
Yeah, definitely be useful.
It's a good thought, thank you.
What did you guys use for like secure storage of the actual password?
It was a vault. Yeah, yeah.
You guys use that as randomly generated too?
Yeah, we had a, so we,
Oh yeah, sorry. So we were the first question was what were we using to store the passwords, and then and it's Ansible Vault. And the second question was were we also using Vault to generate the passwords?
and yes. Yeah. Which again came later. Hey, look, we should be doing it this way, and so we refactor our tooling to do that.
There's definitely not an easily guessable default password anywhere in any of these
Shut up, you.
old Git commits.
Yeah.
Cool.
We good?
Well, thank you guys. If there's no other questions, thank you guys so much for coming. You're welcome to reach out to us. We'll be hanging around. Yeah, if there's anything you need, take care. Have a good day. Have a good summit.
Enjoy lunch.
Yes, enjoy lunch.